Okay, let's go. This is our last session for the day. And so the idea is to show a little bit an initiative we have started lately at ETSI in order to host and enable collaboration across SDGs. I would like to start by a quick roundtable because we have really nice wide and diverse range of people here representing all SDGs. So I'm really proud of this line of speakers. My name is Silvia Almagia. I am Director of Software and Standards at ETSI, and I'm leading the team that's supporting and nurturing all these software development groups at ETSI in support of standardization.
Thanks. I'm Christos Tranoris. I'm from the University of Patras in Greece, and I'm the chair of OpenSlice SDG.
Hi, everybody. I'm Giulio Carota from EURECOM. I'm an engineer there, and I'm here as a main contributor to the NEF project that we have at EURECOM.
Hello from my side too. I'm Stavros Charismiadis. I work for FOGUS Innovation and Services, and I also am a part of the OpenCAPIF SDG.
Hello everyone, my name is Dimitris Gogos from Intracom Telecom, and I'm the chair of the technical committee for OpenOP.
Hello everyone, I'm Kostis Trantzas. I'm affiliated with the University of Patras and I'm the Technical Steering Committee Chair of OpenSlice.
Hello everybody, my name is Lluis Gifre. I'm Senior Researcher at CTTC in Castelldefels, Barcelona, Spain, and also I'm the Technical Steering Committee Chair of the ETSI Traflow SDN.
Hello again, Francisco-Javier Ramon from Telefonica, multi-cloud tools manager, and also I'm serving as chairman of ETSI OSM.
Okay, so let's get started. This is the agenda of what we're going to see over the next hour and a half. We're going to present Christos and myself a little bit of the reason for this joint SDG lab. And then we're going to go little by little through all the different integrations that have taken place during this activity. So we'll see how integration between OpenCAPIF and EURECOM's NEF, between OpenSlice, OpenCAPIF and NEF, between OpenSlice and Open Source Mano, Open Source Mano and Teraflow SDN, OpenSlice, Open Source Mano, Teraflow SDN, and lately between OpenOP and NEF. At the end, we're going to reflect a little bit about the lessons we've learned with this exercise and some plans for the future, and you will have also some time, hopefully, to ask some questions. So first of all, why this joint SDG lab? If my memory is correct, this started when we were defining the hackathon challenge. We were thinking that we should aim to have developers to integrate and work with as many SDGs as possible. And then we had the reflection, okay, this is going to be pretty challenging. Would we ourselves be able to do it? Okay, so we decided, okay, we go with the hackathon. It will go with at least 2 SDGs, 2 components. And in parallel, we start preparing a demo where we try to solve something with all the software, all the SDGs. And the idea here was not to create a one-off demo, but to provide some sustainable environment to enable this cross-community collaboration of open source software in support of standardization. So we've created this, not only this joint demo, but also this joint lab that will stay. After this demo today, the lab will stay and we will keep constructing. So it might not be amazing today, but the idea is that we will make it amazing with time, and it's quite, I think it's quite remarkable. This discussion was taking place, I was checking the messages, was end of October, November, when we started with this crazy idea of putting it all together, putting all the SDGs together. And just to give you an idea, our latest SDGs OpenOP started in July, so it was pretty early stages for them. And the idea here is, as I was saying, to provide a long-term home, long-term extensible and neutral environment where the different SDGs can come together and test and integrate. And we might have a couple of use cases today, and probably more will come with time. And the idea also is to demonstrate that by plug and play in these different SDG components together, we can achieve much more and solve much more complex use cases. So this is how it started. We have a private cloud based on OpenStack that we set up a long time ago to support OSM testing and to support our CI/CD and some hackfests and so on. Then Teraflow SDN with time came into the picture, and they were asking for some space for testing as well. So we created some space for them. And then we started discussions on how to integrate OSM Teraflow SDN. This was probably the very first two components that we tried to integrate. And then the other SDGs came along, and with time, we need to provide them some space for the runners, for the testing, for their sandbox, and so on. So little by little, we had like little silos where each SDG had their own space to test and experiment. And what we decided a couple of months ago is to create some common space alongside and create some number of different networks and some common networks where the different components and the different communities could start testing with each other. So this is an environment that's hosted at ETSI right here, and each community, wherever they are, wherever they're based, they can connect over VPN, access to their own environment, and also access to the common environment. We also decided at a time that we would invite our neighbors and friends from EURECOM to bring their network exposure function that provided a nice, was quite complementary to what we wanted to build, and was also some points of integration had been demonstrated 1 year ago.
Okay, I will take just a couple of slides. First of all, to continue from the Silvia's, what she said nicely, I would like to mention here that ETSI IT, to our understanding, is not made for that. It's a challenge here, and I would like to thank, on behalf of everyone here at ETSI, because you don't understand what's happening behind, but it's not only this testbed that you see. There are 5 or 6 repositories now in parallel that their IT need to support. Because they support also, they host our source code, commits. We have nightly builds. Now, each one of you, not only you, but European projects, many stakeholders that they download images. We build images, we make nightly builds, images are there, and they need to download to their infrastructure. So we have made significant traffic. I know some people here that they laugh, but this is huge. And this is really important. This is a challenge for ETSI. I don't know. I hope that you will handle this demand now, okay, in your role. So they decide to create, it's a kind of a new testbed, and it will live, okay? It is a playground for us. And the goal here is to show best practices of the software, because all of us, the community ask us how you combine this or that. Or, these components make the same functionality with this component. So why you are doing this? So we try to show best practices and experiences from how we deploy our software, how we use it, and in the long term, use it with real life use cases. Maybe connect these testbeds with a real infrastructure remotely, okay? So this playground will showcase how we use our software in various scenarios, okay? So combine 2 or 3 of them. You have seen from our demos that you pick 1, 2, 3 of them and you solve a case. So this is the idea. And also you also understand that there are cross-cutting features. Technology is moving. You see that 2 or 3 SDGs, they need to implement same features, same APIs. We're following standards. We need to cover, demanding technologies. We have different needs. So you will see that there are features that maybe are the same. Another point, we need to support scenarios that they tackle different life, the life cycle of service and resource that we offer. It's not everything for all parts of the life cycle of a service or of a resource. Some part of SDGs are very good for provisioning. Some parts are good for the operation of the service. It's not the same that you use everything all the time, okay? Or closing a loop. So this needs to. It's very difficult. You know, all of these components have a very, very difficult learning curve. So you need to understand how you sit from the perspective of a telco provider or a cloud provider of of connectivity. So this is what we want also to demonstrate. The usage from various stakeholders. How a CSP will use the software. How an administrator will use it. How a developer will use it. Which components of the software. Or single users, or even researchers. Researchers use differently our components. They will dig into the source code. Okay, the CSP will use it, differently. So this is our goal here, and we start this journey. We will see if I hope we will be successful, okay, in the next months and years, I hope. Julian here will kill us, but and all the whole IT department. But anyway, I hope we will be successful really in this effort. This is an example, okay? We started this. I mean, this is it could be a case that everything is in place. And again, as I said, we can have multiple configuration and setups, but one case that everything could play, that was an initial picture, what we have. For example, we would like to have, in the famous now telco cloud scenario that you have the core somewhere, you deploy on easily on edge side, user plane functions near the radio. You need to maintain your APIs, deploy on demand other services, monitor and operate the service on the different services of how it operates, etc., and expose it, of course, to the end users and developers, not only to the CSP and to administrators, to your users and developers, and easily manage everything. So, for example, how you do that? Usually, you need a management domain. So this is the idea. And what we have developed here at ETSI, it's a management domain. It's what you would like to have in order to operate the resource of your infrastructure. So in this management domain, we deployed all the components here, okay, OpenSlice, OpenCAPIF, Open Source Mano, Teraflow, SDN, OpenOP, and then slowly we will try to interact and deliver useful scenario. Here is an example, okay? The guys here will show you different parts of this whole picture. But what is the scenario? For example, the scenario is that you have a core domain with a core, and then you have an edge domain. And near the edge domain, which are the radios, for example, near it, you need to deploy the user plane function and maybe an application. And then easily, OSM can prepare this infrastructure, okay, the parts of deploying and configuring the Kubernetes clusters and deploying resource, deploying network functions, configuring them. Then we have TFS to interconnect and prepare the routing of these services and have interconnection and playing there. And then we have OpenCAPIF exposing securely to the other 3GPP services the underlying infrastructure service, especially the NEF, or other parts of the 5G core, since OpenCAPIF is a core 3GPP exposure service. Then OpenSlice orchestrating and demanding this on the deployment phase of first initiating and bootstrapping all this environment, even scaling later on or monitoring how it performs, and also OpenOP leveraging the infrastructure and exposing through Camara APIs the related service that created. Okay, so this is a big picture. This is one scenario. You have seen these 2 days, different setups. You will see also there will be demos in the next 2 days that they use all these components in other ways, in different ways. But this is a scenario that we're working here, okay? And I will now move on to the respective TSGs to show you how, in these big pictures, 2, 3 of them collaborate on each part. And again, imagine that the components, other components are used during deployment phase, other components are used during operation phase, and each one have their own role, okay? Today here, we're not fully prepared, okay? This is a moving target. We will show you a few things here today. During the upcoming months, we will have more things. And as we said, this is a platform that is here to stay for all of us to experiment with. And hopefully in the future, even other infrastructures connect here and play with these deployed services, okay? I hand over to the next speaker to start preparing this cross-SDG integration. Yeah. And handing over to Stavros, I think, and Giulio.
Yes, so I will make the start. The first demo is includes the OpenCAPIF, the code from OpenCAPIF SDG, and the code from EURECOM's NEF. So this first demo will showcase the actual 3GPP standardized exposure of 5G NEF APIs, leveraging two open source projects, the OpenCAPIF and the EURECOM NEF. Both components are hosted on the ETSI infrastructure, and actually this first demo will contain NEF onboarding to CAPIF, and then later NEF publishing its APIs to CAPIF. So just present the demo steps. As I said, the two components are already deployed on ETSI infrastructure. The first step will be on the NEF component to deploy a NEF CAPIF connection service, which will actually onboard the NEF to CAPIF as a provider role. Then on the NEF component again, a first API will be deployed inside, and while deploying, it will notify the NEF CAPIF service, which will instantly publish the NEF API information to the CAPIF. And whenever a new API is deployed on the NEF component, again, we will follow the same procedure, notify the NEF CAPIF service, and then publish the corresponding API. So in that way, we keep a connection between the CAPIF and the NEF. And so I will pass the floor to you, Giulio, to make the demo.
All right, so thank you, Stavros, for the introduction. So what I'm going to show you, it's going to be live. So hopefully everything's going to be all right. I'm going to quickly deploy the network exposure function. We have manifests that are public and are available on the project website, GitLab repo. So everything is based on Docker Compose. I will quickly deploy everything. So the NEF is a cloud-native architecture. Each northbound service is implemented as a different microservice. And the scope here of the implementation and the architecture we chose for integrating with CAPIF is to align the API lifecycle, let's say the microservice lifecycle, to the API lifecycle. So when the API goes up, it is published. When the API is teared down, the API is removed from CAPIF, which is something that is highly going to happen in cloud-native environments. So first thing first, I would like to show you the logs of the NEF CAPIF service that we call CAPIF connector. And from the logs, you can see that the NEF is now onboarded as a provider. All the certificates have been signed by CAPIF, which means that we are securely exposing our NEF instance. And then you can see that we have different logs in which we publish the 3GPP APIs to CAPIF. We have single logs for each APIs because, of course, this procedure is done for every microservice. So just to show you, we have the CAPIF database that has been provided by OpenCAPIF on the right. And you can see first thing first that the provider is onboarded. We have the provider information and secrets here, but also that the applications, the services are onboarded. So you can see the different APIs that are inside the database, which means that they have been successfully onboarded. One thing that I want to show you as well is that what happens when an API microservice, for example, is terminated because there are no resources available. It's an orchestrator choice, for example. I will simulate this by using Docker compose down and the name, sorry, I will just go to the directory. Right. So I will use Docker compose down and the name of the API, for example, monitoring event. So the API now it's removed, and you can see in the logs of the Capif connector that the service has been deleted, and we can see as well in the Capif database that if we refresh the page, that service is no longer available. The way we decided to implement this and this architecture is to, as I said before, to align application and microservices lifecycle and APIs lifecycle. Because in telco cloud environment, APIs are a constraint. Some application will require APIs, and sometimes we cannot ensure that the APIs will always be available. So using Capif, we can securely expose this API to the vertical applications, but also we can inform the orchestrators and the applications about the API lifecycle. They can be terminated, they can be not available anymore in a zone, and this is how Capif can help verticals to explore and use 3GPP APIs. So what we saw right now, it's the provider perspective, a 3GPP function onboarding the APIs on Capif, and I will hand over to Kostis, which is going to show us the invoker perspective, how those APIs are consumed using Capif. Thank you.
Okay, thank you for the token, Giulio. Let me share my screen. Okay, and start over this demonstration. Actually, this demo is a perfect natural succession on the previously published APIs, because it will programmatically invoke one of the elected published NEF API via OpenSlice, trying to abstract the Capif flow in between, because the security flow of Capif can be quite hard to follow for a newcomer. And if you indeed don't want to get involved with that and you just want the data in a secure way, this is a place to be. It leverages two SDGs, OpenSlice and OpenCapif, and one open source project, which is the EURECOM's NEF. All the components are deployed in ETSI infrastructure, and it assumes that the NEF is onboarded and the APIs are published. Good thing is that we have a demo for this, a video for this demo, because the example that Giulio elected to take down was the one that we were using. So it won't affect, though, the demonstration. But what you will see is an abstraction of Capif flow within OpenSlice. It will onboard an invoker live in Capif. It will select a specific published API. Spoiler alert, this is the monitoring event. And it will access, it will handle the access token creation and refreshing. And we shall see that it retrieves an response from the selected NEF API and extracts the cell ID of a specific device. So the demo flow will start with OpenSlice, or I think this is implicitly stated that OpenSlice will authenticate with the Capif core function initially. And this authentication is maintained throughout the lifecycle of the controller, the respective controller. Next, some user would need to select the appropriate service, I would say a B2B user that wants to retrieve NEF metrics to trigger a typical service order. When this happens, three steps appear sequentially. So the first one would be that OpenSlice will onboard an F invoker in CAPIF using the authentication token with the core function. It will retrieve the published service API and request access token for the selected API of the invoker, which will be the 3GPP monitoring event. After that, a token will be generated through the CAPIF core function towards the selected NEF API. And using this token, OpenSlice will trigger NEF so to get a response from the respective endpoint. So the video that showcases this is appearing here. So this is a service that we said that someone would need to order. This is a customer-facing service and offers the functionality of subscription to this monitoring event. Of course, we have to have the realizing service, as we see now, which will onboard the invoker and execute the sequential steps. At the end of the day, of course, we have to define somewhere the business logic, which is after the invoker is being onboarded and the bearer access token is retrieved, you have to trigger the northbound interface of NEF to request for a monitoring event, and this will be extracted as separate characteristics as you shall see. So this is the typical catalog browsing. The user elects this specific service. Here she places the order, and the order is then fulfilled by an administrator. So the fulfillment process implies these sequential steps. As it is, the state is change in progress, the order is starting to fulfill, the services appear, and the first service means that the invoker is onboarded and the access token is retrieved. And if we see refreshing the CAPIF UI, you will see the invoker onboarded. At the end of the day, though, we need the NEF response, and that's it. So it used the bearer access token you saw in the previous service and retrieved the UE location. So that was the demo, a short demo that showcased a secure 3GPP defined way of interacting with NEF, but without the need to actually explicitly authenticate with CAPIF beforehand, because a secure invoker, aka OpenSlice here, does it for you. So switching a bit the context out of security scope, here we have a demo between OpenSlice and open source Mano. For you that you are familiar with this integration, you have seen it many times. To be honest, we are using the imperative API and not the fascinating declarative way that OSM operates this time, as Francisco shows us previously. But we have to start somewhere. And I mean, having a basis that actually works is the best to start with. So what we want to do here is to employ these two SDGs to deploy an indicative 5G service and an open 5Gs core with simulated subscribers via these two SDGs. Again, all the software components are deployed in ETSI infrastructure, and it assumes that the NAV artifacts that will deploy the core and the simulator, URNSIM, in fact, are already onboarded on OSM. We have created them ourselves, but we assume that they are already onboarded, so they can be synchronized. What this demo abstracts is the deployment flow of this situation. So it will synchronize NAV artifacts in an open source Mano instance. It will design the orchestration flow, because the orchestration flow implies that first we will deploy the 5G core, and once this is ready, we can deploy the simulated UEs and radio access network. And then we will deploy all the network services in that sequence as we've said. Last but not least, what we would have is, and this demo will showcase, is a deployment of a 5G core with user-defined numbers of subscribers, as we shall see in the end of this video. So again, we start with the high-level architecture. So to facilitate this connectivity between these two SDGs, OpenSlice now uses a different type of controller, the NAV Solo 5 controller, which is defined by ETSI. And it was the imperative northbound interface of open source Mano. And with this interface, it will synchronize all the respective NAV artifacts. Then, in a similar way of the previous demo, a user will request to deploy a 5G system with simulated subscribers, with him defining the number of these subscribers. And then the 5G will be deployed first, and second, the simulated UEs and radio units will be deployed as well. So what happens then is that Open Source Manual will use the synchronized, or I would say onboarded, virtual infrastructure managers, aka the Kubernetes cluster that is underlying, to deploy the CNFs of both the core and the simulated radio and UEs. So without further ado, let's jump to the demo again. It should be here. So again, let's start with the design phase. This time it's a bit more different because we have a bundle service here. We have two services. We have the 5G core deployment and the URN SIM. And the business logic is a bit different because what it does is trying to hold the deployment of the URN SIM until the first service is active. So again, we expect the user to browse through the catalog, select this service this time, place it in the cart, and elect the number of subscribers of its preference. Here is 10 for this demo. So again, the order shall be acknowledged by an administrator and given the known state. As we expect here, we have dependency chains. As we've said, indeed, first, the 5G core is deployed. So the respective service is created in OpenSlice. And what that means is that the request is delegated also to OSM. And obviously, this service, network service in OSM, will deploy the 5G core in a Kubernetes system. As it is deployed, then we shall see that the respective network services are becoming active, both in OSM and OpenSlice. As you can see here with the green state, the 5G core is active and the URN SIM can be deployed as well. Again, in the same manner, we see a new network service being deployed in OSM's UI, and respectively, we see two new pods in the Kubernetes environment. As they're getting ready and they spin up, we can observe the logs of the UE part, let's say, of the simulated environment. And we shall see in the logs that 10 simulated environments or UEs actually are being created. And that is what we see here. They get IPs up to 010. And from the 5G core side, we can see the UPF logs, respectively, that respectively 10 UPF tunnel sessions are being created as well. So with that, of course, all the services are active. The initiator, so the service order is marked completed, and the 5G core with the simulated subscribers is being deployed. So that was the demo on this collaboration between OSM and OpenSlice, and now I pass the floor to Lluis for the next demo.
Yes, thanks, Kostis. Let me share my screen. Okay, so in this case, for this demonstration, what we are doing is to showcase integration between OSM and TFS. The idea behind is that, okay, in most cases you see OSM deploying things in a specific domain, in single cluster. But when we incorporate TFS, what we can do is things like, okay, let's have multiple domains interconnected by a transport network. And the idea is to see how to deploy something that spans multiple clusters, okay? So here the point is we will deploy one service that will span a couple of domains, and then TerraFlow will be providing the connectivity between the two domains, and we will check that there is connectivity. Let's go for the demo architecture quickly. The idea is, as I was mentioning, we have the two softwares, OSM and TFS. They are deployed here at ETSI at the Common SDG Lab. Then we have also a couple of sites where we have one cluster in each site, each of them connected to a virtual network. These two virtual networks are interconnected by means, in this case, of a container lab emulated environment, a data plane with 3 routers. And they are providing the connectivity between these 2 different sites. Then what we will see is that whenever we issue the request for deploying a multi-site network service to OSM, OSM will first deploy the appropriate workloads in the different clusters. In this case, we are using as a toy example OpenLDAP for simplicity. And after that, OSM will interface with TerraFlow SDN requesting an IETF layer 2 VPN service request for establishing the connectivity. Essentially, that means that TerraFlow will be configuring the appropriate routing and forwarding rules in the different devices to enable the connectivity. Okay, so having said that, let me jump to the demo. To make it funny, maybe we can try live demo. Let's see what happens. Why not? I think might go wrong. Today. So here it's the ETSI Common project where we have the cluster A. This is essentially running a Kubernetes. We have also here the container lab, and also in the other project we have OSM TFS. Here we have the second cluster. So I connected here to both of them. Initially, you can see that there is nothing running about. Well, there is just the typical services. For sure, OSM was already configured and did the initial configurations of the flags and so on. You will help me with all the details of OSM because you are the expert here.
In case there's something that.
Yeah. So
far is good.
Yeah. So the service that we are deploying is this OpenLDAP. It's I just borrowed your examples on OpenLDAP. It's just extended in the network service descriptor with a couple of instances for OpenLDAP. Okay. Mm-hmm. Besides that, I was also configuring the OSM with the appropriate WIM accounts with the appropriate port mapping for the different sites. So it results at the end that in OSM we have all the bits and pieces. So we have the OpenLDAP network service. We have also the OpenLDAP KNF. Right now we still don't have any instance running. And in the accounts, we have the 2 sites, site A, site B. And they are also configured the 2 Kubernetes clusters. I will not go through the rest because this is for the next hackers. I kept it simple in this one. Important thing is with the WIM account, we have also TerraFlow configured here, and you see that everything is in green. Then more things. We have here also in TerraFlow onboarded the topology. At the beginning, we have no service configured here. So yeah, that's it. So we have everything here. Let's try to break things now. So we go to OSM, instance, network service. We deploy a new, it will be the LDAP multi-site. LDAP multi-site. We will use the OpenLDAP for multi-site that I was creating, we choose one because with the configuration it will choose the others. And here I need to choose the parameters that I hadn't shown. And it's interesting to see because the parameters essentially define the virtual link descriptor for the management network, that is the one that we are using here, which is the name of the network that each of the KNFs should use. Okay, then here I'm specifying for each of the BNFs at which beam they should be deployed. One goes to site A, the other to site B. And then we provide some additional parameters for each of them. So specifying, for instance, the images, the usernames, well, passwords, authentication, load balancing, blah, blah, blah. Let's see what happens. So we create. Now it's started.
This is essentially what makes it replicable outside of its infrastructure. So if you change these parameters and keep everything else, it will work, right? So.
Yeah, exactly. And we see here that it's deploying things, which is good. Essentially, we see here that OpenLDAP, the first one, it's running. The second one, it's running 1/1. Perfect. This is ready. The first one, it's still starting. Okay, 1/1. This one, it's ready. So now I should be able to try to perform a request on the other side. Okay, still not. Might take a while, or maybe as things happens with demos. Ah, no. Okay, now it's working.
Be patient.
Yes. Oh, interesting. One of them, it's okay. Now it took a bit of time. Good. So it worked. That's good. Okay. So this is essentially this part of the demonstration. Whoops. Okay. And maybe I can start with the next demonstration, which essentially it's ongoing work. This one, it's not completed. It's the idea that we have for integrating OSL, OSM, and TFS and showcasing how they interact in a single use case. So the idea here is that we elaborate on top of the previous demonstrations that we were showcasing. And the target is, okay, now we have OSL, we have OSM, we have TFS. We start now with 3 domains. We have one core domain. We have one core domain, one edge domain, radio access network domain. We can connect them through Container Lab in a similar way as we were showcasing. And then with from OpenSlice, we initialize the SDN fabric through Teraflow. Then OSL will deploy the appropriate 5GS components in the different clusters. That means, for instance, the Open 5GS system at the core, the UPF at the edge, and maybe a URN SIM at the RAN. And after that, OSM will trigger the site-to-site connectivity, configuring in a similar way the routers in Container Lab that will provide the connectivity. After that, ideally, OSL should be able to configure the different elements in the core, in the edge, and in the RAN. This is indeed an idea of how we can proceed for the next. And yeah, and maybe, I don't know, Kostis,
No, I just wanted to mention that, I mean, this shows what is the long-term objective of this, is that, I mean, because as Silvia has said, I will say it with different words, the demonstrations that we've seen so far are rather technical, because, I mean, we are building one-to-one trust, one system trusting the other. So they collaborate to do something more sophisticated together, but they are rather technical, the demonstrations. However, the nice thing after this phase is that now that trust is composed by the different components. So you can be braver in building complex use cases because you created the foundations in this round. That is precisely what we are building. The long run is that you can run with the latest version of each of the components. The interfaces are polished, so we make sure that interoperability is as perfect as we want it, so we can trust each other and we can compose the benefits of each of the components in a map of systems that they can collaborate together, and we can be brave of building sophisticated use cases afterwards. So that is precisely the motivation of this. So now you see one-to-one relations, and it doesn't seem super ambitious, but the long-term plan is precisely to combine them, being very brave because we trust each other.
And actually, this demonstration that we are proposing, it's there is some building blocks that Kostis can share here.
Actually, we keep sharing? Yes, it's fine. Okay, so this integration is not new. Maybe to your eyes, you've seen it in the past SNS4SNS, but we had this environment, but on private cloud of University of Patras. So we want to replicate it. So we have a basis to build upon. What we did back in the day, in the previous SNS4SNS, it has a QR code to follow. There is a video, there is demonstration, there are slides, but we don't have time to show it now. It was huge, to be honest. So what we did was split, let's say, the concerns into facts. First, it was the creation of the network fabric. So we utilized at the northbound interface, we expect that the user issues a service order in TMF word. This is translated to IETF requests towards TFS to create the underlying network fabric between three domains. So the first domain would be the core domain, or we say a domain that a local mobile network operator operates within the country, was connected with an edge domain through a simulated container lab environment. So this environment, or this simulated chain of routers, was deployed dynamically using OSL and TFS, respective OSL and TFS service. Then we had to connect the edge in the corporate environment. The corporate environment, we were assuming that there is a restrained environment. Maybe it has resources, but these resources had to be secured. So in that way, when we fixed, I would say, the network fabric between the edge and the corporate, we were not caring only about the routing, but we wanted also to handle user access. So for that, we implemented and deployed P4 rules through TFS on a softwareized P4 router, switch rather. So it handled the routing and user-based access. So this is the network fabric. Now, switching over the deployment, the actual deployment of the 5G system, we wanted to have a disaggregated 5G system with multiple slices. So we leverage again a service initiating from OpenSlice, triggering the same interface that we saw earlier to deploy a 5G core on the core domain. So we deployed a fully blown 5G core along with the first UPF, which had a domain name of internet to replicate, let's say, a typical 5G connectivity of a country's operator. Then what we wanted to do is to interconnect this 5G system with the edge domain, which was in a more private and restricted environment. So what we did was just to deploy a UPF there, only UPF, and interconnect this UPF to the previously deployed core using the same interfaces. And also the connectivity between this UPF and the deployed core was achieved by the integration fabric between these two domains that was initiated in the previous step. So this was the, I would say, this is the explanation of the left side of this picture. And at the end, we showcased it with simulated subscribers because we couldn't move, of course, radio units around. You would expect that. So what we did was to simulate the radio node at the core domain and the subscriber, as you can see at the right part of the screen. And this subscriber acquired the IP address of 10.45.01. So this was the DNN internet. And indeed, we tried to reach internet out of this subscriber, and it actually happened. So this is a subscriber, a typical MNO subscriber. Then we switched over to the core edge environment. We replicated this experiment. So we had the radio unit there, another subscriber, simulated one. But this time, because the subscriber connected to the second UPF, it acquired a different IP address, as you can see. It's 10.46, which is a DNN work. So this DNN domain name imposed restrictions on access. So this subscriber couldn't access the internet, but could access open corporate services through the P4 fabric. And then we tried with this device to access the restricted corporate services, again passing through the P4 filtering, which failed. And then to showcase that indeed there are restricted corporate services, we used a PC with a VPN residing in the corporate domain, and we access the restricted corporate services directly through a VPN connectivity. So this was the demo. It was a fairly ambitious one. It took us, I think, 4 months to set up and have it running as we wanted. Many moving parts, and it was easy because the infrastructure was actually easy to destroy because it was managed by us. So because we don't want to do that in ETSI, we'll take small steps this time, and hopefully we'll have it ready by the next time you see us.
I think now we switch over to OpenOP, EURECOM.
Great, thank you. So quick introduction from my side before handing to Giulio for the live demo. The scope for the OpenOP demo is to demonstrate the interoperability between OpenOP and the EURECOM network exposure function. We'll be showcasing how we use Camara network APIs to enable different programmable network capabilities, and how OpenOP translates application-level intents to specific 5G core NEF operations. This is the setup of the demo. So we have 2 VMs in the ETSI servers. In one of them, we have deployed OpenOP, and in the other one, we have the Open Exposure NEF and the core network simulator. So we'll see how a consumer can send his intent via Camara API. This request comes to the Open Exposure Gateway, where we validate and we authenticate. And then we forward this request to the service resource manager, who starts to plan the orchestration for the end-to-end result, and uses transformation functions that will trigger the specific APIs of the Open Exposure NEF. And we will be seeing the actual effect on the core network simulator. So from the OpenOP side, we are providing the Camara compliant APIs, and for this demo, we'll be using the quality of demand and traffic influence Camara APIs. The Open Exposure NEF from EURECOM implements 3GPP standard NEF APIs, like the 3GPP as a session with QoS and 3GPP traffic influence. It acts as the bridge between OpenOP and the operator networks, and it allows for abstraction and concealing of network-related capabilities. As I mentioned, we will be using the Open Exposure Core Network Simulator to demonstrate how the Camara API call will be propagated end-to-end all the way down to the network and the user traffic. And Giulio will show that in the dashboard of the simulator. So I can now hand over to Giulio.
All right. So thank you, Dimitris, for the introduction. So what you can see and what you saw in the previous slides, about the architecture, we are going to make a call to the Camera APIs exposed by open exposures. This call will be translated to a 3GPP compliant call to the NEF, and then the NEF will communicate with the coordinator simulator still using 3GPP compliant interfaces. So what you can see on the right, it's the Swagger, it's documentation of the OpenOP platform that allows us also to directly call and invoke APIs. And what you can see on the left is the Grafana dashboard of the core network simulator that we have developed at EURECOM, and that supports QoS policies enforcement on user behavior. What I will be showing you as well are the logs. So you can see on the top left the NEF logs of the AS session with QoS APIs, which will be used for QoD scope. As you can see, the NEF is configured to have a mapping of QoS profiles into QoS requirements for the core network, and you can see on the bottom left the logs of the core network simulator. So as you can see, there is only one user registered. This is how we configure the core network simulation. The user has a default QoS flow, default QoS policies that it's limiting its throughput to 80 megabit per second, both in uplink and downlink. What we want to achieve here is to use Camera to activate a dedicated QoS policy for that user in order to increase the available throughput for the user and to allow, in this case, an edge application to take advantage of the available bandwidth and capacity. So, sorry. As you can see on the dashboard, the user throughput is limited at around 70 megabit per second. This is because we have the operator's policies that is blocking, is limiting the capacity. Now we are going to proceed to activate the QoS flow profile, the QoS profile, which is called QoS-E, that, as you saw in the NEF logs, is mapped to 40 megabit per second of minimum guaranteed bandwidth. So this will, of course, result in an increase in the available throughput for the user, and the user will take advantage of it. So you will see it in the graphic, in the traffic logs, that the total throughput will increase. So in order to enable this session, we will be using the QoD functions, and we will use the post call. I'm going to show you and go through the API body. So as you can see here, it's really simple. It really abstracts the complexity there's behind. This is a complex setup. Everything that it's involving QoS and policies, it might be quite difficult for applications to understand, especially in 3GPP domain. What OpenOP is doing here is to abstract and to reduce complexity. The only information we need is the address, the IP address of the user, which is known by the application, the IP of the application, and the profile that we would like to activate. So you can see all this the information is here. We can execute the call. The call is successful, so the QoS has been requested, and you can immediately see in the traffic throughput graphs that the throughput has indeed increased to around 110 megabit per second. We can check the status of this QoS policy by using the session ID that is returned by OpenOP. Use the get endpoint. Sorry. We can try it out. We can execute the call, and then you can see that the QoS is available, and indeed you can see also it in the simulator. I will just quickly show you what's happening in the logs. So basically, the simulator has received the policy that has been translated by the NEF. The policy, as you can see, has some requirements in terms of QoS flow, QoS policies, and we are activating a dedicated QoS flow in the UE PDU session. What we can do now together is to remove this policy, because these policies are not meant to last forever. We can use the session ID and use the delete endpoint to remove the QoD policy. So once we execute the call, we will see that it's successful. We receive 200, and indeed the total throughput of the user will return to what was the original and default operator's policy to the traffic. What we are supporting as well is traffic influence calls. I can briefly show you, for example, the post. We're not going into details because it requires a more complex scenario. But indeed, what you can do here is to activate a traffic influence policy. This policy will indeed influence the way the traffic is routed in the 3GPP network in order to offload and to reduce latency or use the optimal route to reach the edge application. So still, we just need to indicate the UEIP, the region where the application is of course located so that we can organize the routing, some information about the application. We can execute the call. You can see the call is successful. And what happened in the simulator, you can see that first thing first, we received the call in the 3GPP traffic influence API of the NF. So we have a post request here. And the core simulator received a policy authorization for UE that is about the traffic influence. Now, this is a limitation of the core simulator. We are not able to orchestrate PDU session topology changes yet, but this will be done soon. But it's supported by the NEF. There are some open source core networks that support it. And of course, this demonstrates also that OpenOP is able to handle this kind of requests and APIs. So I think that concludes my demo. And I will give back the word to probably Silvia.
Yep. Thank you, Giulio. I believe we can hand over to Christos again.
Okay, we are concluding this session, and of course, as I said in the beginning, this is a moving target. You know, it's a live thing. We just started. For our starting point, first of all, we try to understand with this setup what is the component I'm mentioning, because we try to understand what is needed. And to have such a setup, I said to you in the beginning that you need a management cluster to install all these components. So what you need exactly to properly operate these components. The next thing that we need to improve, of course, it's many times, of course, the documentation. A lot of configuration is needed and needs to be communicated properly between the teams. Continuously we identify new issues, especially since we have, you know, new releases, new software coming, and you see software, especially open source software, comes usually with an effort of people that, you know, it's not free, and they put their time on it, and it's very difficult for us to test everything and all the setups. So, you know, you install the latest version, then you see that this configuration was working before, now it's not working. You don't have the expected behavior. You need to update also your part. So already we identify issues and we solve them. And the last thing, of course, that we see is that standards themselves to support them is quite challenging. And if you have developed things yourself, you will see that sometimes you can bypass some things and do it, you know, your own way because it's faster. This is good and this is bad. Sometimes, you know, it's good because you are faster. It's bad, but you are not following the standard because you are bypassing things. You can bypass security, you can bypass a flow and directly hit a component because you like it, but this is not the way things that they work. There is a positive things behind. then this is the purpose of the SDGs, is to change the standard. Because we saw something that someone thought that it works, and in practice it's not working. It's quite complex, and there are simpler ways to do it. So this is also an outcome of this work, and for sure for the future. And this is our purpose also, the SDGs, to be used for pre-standardization efforts, and play with the standard and see how they work. So next steps. This playground, as I said, is here to stay, and we will constantly demonstrate new features and how we collaborate together, display synergies and capabilities, synergies beyond SDGs. Okay, the goal here is also to easily integrate third parties if it's possible, with, of course, the help of ETSI, which they will enjoy it also together with us. Another goal, as I said, is to solve early integration issues between our solutions, to test the latest releases of our software and how we play together. Another thing is to provide ready-to-install examples. It was mentioned previously, these 2 days, you get a software and suddenly you don't know what to do with that, and you need to learn about that, to have a learning curve and all these kind of things. And I remember from the past, since 5 or 6 years ago, when we were doing more things with open source Mano, it was also a need to have, for example, a CNF marketplace. Things that someone can download from a repository, open source things, like you have Helm things, but now we can have packages ready to install somewhere. Okay, so someone can really easily replicate what we have on their own premises, ready packages. Okay, this will be very important. And as I said, this expansion and integration with other solutions from other ecosystems. With ETSI has already agreements with Linux Foundation or Eclipse. So this will be a perfect opportunity to try other open source software from other communities and see how we can collaborate and move forward and see and fill different gaps. Last but not least, something that the guys here will enjoy is that we will have a continuation of this effort. We will have, at least we applied for a UCNC demo booth. I hope that we will be successful. So ETSI will be there at the UCNC 2026 this summer. It will be in Malaga, Spain. And again, you will have the opportunity to experience all SDGs there in action. I hope with more mature, cases and more issues solved. That's it. I don't know. If you have questions. Thank you.
I don't see the time any longer, but I think we still have a few minutes for questions.
Was not pressing the right place. Well, first of all, it's fantastic the work you are doing, and it's much more valuable when you see that interacting and being integrated and providing full solutions for many use cases. So I think it's a fantastic job. I understand the work of these SDGs is also trying to complement the standardization work. And something that will be interesting, and this is a suggestion for the future, is not a question, is also to see how all these SDGs are contributing to different groups, standardization groups in ETSI, and how the roadmaps for software development and standardization are, somehow being orchestrated. Okay, because I think that the result of this will be standards that are much more solid. Okay, because they have been based on software that is working and probably tested before the definition. No, that is something that I think will improve very much the value of the standards. Okay, and in this sense, is this something that you are already doing? The question would be, so you are tracking this alignment between deliverables here in the SDGs and releases of different technical specifications on the standard side.
Yes, so yeah, thanks for the comment and good question. Yes, indeed, we don't aim to become the next open source foundation. We are hosting software that's somehow related to standardization at ETSI or outside ETSI. We're seeing that we're also looking at TM4 APIs, GSMA, and other kind of SDOs. But also if we're hosting software, it's because it's somehow related to some standardization work. We do encourage and coach our SDGs to provide feedback. It's a challenge by choice, let's say. This is done through common membership and through sometimes quite an additional effort, because these groups are focusing mainly on software, but then are also taking very often the burden of going back and reporting what we've learned, or asking for changes in the specifications, or bringing new features. So we have quite some success stories. I hope some will be covered during the 2 days of conference, but we have also OSM bringing feedback to NAV. We have Open CAPIF very, very much aligned with 3GPP and attending meetings and bringing change requests. And now they are creating a task force to make sure that enough people is involved and coordinating, because also 3GPPs are a different kind of monster, and being impactful there requires that a number of companies get together and co-sign the contributions and so on. And we're getting organized to do that. And I think somehow every SDG has some reference standardization work, are very much paying attention to what's there. So very often, sometimes the standard is very mature. Maybe it's like in the case of IETF specs we're following, they're quite mature. They don't need day-to-day feedback. But in other cases, we're making sure that the feedback lands in the standardization group. Yes. I don't know if anyone wants to complement the answer.
Yeah, probably just because of the timing, because I mean, regularly there are synchronization calls between the peers. I mean, in a few weeks in March, there will be a coordination call with NAV just for discussing the declarative framework that is somehow ahead of what they are specifying, so they can get some inspiration or inputs. And actually, they are requesting actively the standards where they are entering in an unknown territory. But we can give feedback on things that maybe the security here is weak, you could improve it in this way. That's one way. The other way is, look, I'm entering into a territory where you are entering already. Let's see how we can be inspired together and reach an agreement. So yeah, that is happening quite naturally, actually.
Yeah. I think very valuable inputs last 2 days. I've had very interesting initiatives from ETSI and open source ecosystem. However, as I mentioned yesterday, my question as a system design architect is, are we looking at putting all these blocks into the larger framework and seeing what each block or each module brings in the value, and what are still the gap for people to further explore the gap areas and try to do something, or even otherwise to understand the overarching the infrastructure architecture and how these individual modules or plugins and on the larger scheme of things, they contribute so that we can create a framework and then see, okay, here we have that TM forum, here we have this GSMA Open Gateway, here we have this, and here these are 4 or 5 of these ETSI initiated initiatives, and this is how they interplay, and then how we leverage them in a structured, granular, and comprehensive manner. That is what I'm looking for as a system architect. Are there any plans to initiate this kind of a architectural approach also overarching, or I'm not criticizing these initiatives, they're very valuable. But I'm not a software person, so I look at from top down and see how they will bring value. I need to understand and then understand what further can be done or needs to be done. Any thoughts?
Okay. We are trying to give, from our experience at least, and how we work, different use cases and demos. There are different views of architecture. Even for us, it's difficult, and it depends many times on the use case. I don't know what is the example that you have on your mind. I mean, the goal here is to have a playground, and then it's time to see how we can instantiate, if possible, and find the gaps for a specific solution, and see how we fit these components in the architecture. We don't have everything. There are many gaps here. Okay, but I don't know. This is how, at least I think. Maybe others have other opinion here. It's very difficult to fit everything. I believe, in a super global picture. I mean, if we bring in our mind the GSMA approach, we have many components here. We have also, if you examine the demos and the use cases, you can find also controllers, transformation functions, that each one fills the big picture. Okay, we have tried this in the past. We have. If you see our presentation, we align, for example, all this software with GSMA and where we place everything. Maybe we should bring such a picture again. So yes, we try to do this. Okay, and yeah, any suggestions are welcomed. Software is agile, let's say.
Yeah, I'm not trying to, marginalize the efforts and the kind of work it has gone into it, and it is continuing to do. But I'm just trying to look at the bigger picture, because see, if I'm an outsider as a stakeholder, I want to set up maybe a futuristic infrastructure. I need to see the architecture for hardware, software stacks, and all that, and I get confused. Okay, as a system architect, which blocks to use and put in my block diagram. And see, when we do architecture, I'm a system engineer. So in system designing, we have different perspective, different viewpoints. So there would be an information flow, data flow, then there will be logical flow, there will be physical, there will be deployment view. There are multiple views. And somewhere we need to have at least 4 or 5 critical views documented in the flow, so that different stakeholder, based on where they are coming from and what is their focus, they can understand how do these things interplay. What is the interconnection between different blocks from that point of view? That was my only point. For example, I can give you the background. When 5G came, everybody said 5G is all about use cases. Am I right? But where are the use cases? We have 5G, but where are the use cases? Why? Simply because it's an outsider view. So yes, 5G is all about softwareize, and the software technologies are exactly the same that have been developed by the IT ecosystem earlier, which in 5G or this telecom people have also adopted and embraced and taken beyond them. Absolutely, no argument. Now, but the point is this: the telecom people are not good at developing the use case applications, because they are more focused on the core infrastructure, which is more critical for them, and there's no argument on that. There's no dispute. The point is, now someone needs to do that, and the IT people who can do the applications, this thing, they don't understand 5G, 6G. We need to make it simple, but with so much of nuances, they get confounded. How do I develop this thing? How many APIs? And which APIs? Kebara, OpenCap, this and that, and GSM, open this thing. They get this thing. And even telecom players, telecom service provider, their main focus is on giving the core infrastructure. So far, what we have seen is enhanced mobile broadband. No, not much URLC or MMTC. And going forward in 6G, we are going to have multiple further expectation. How do we expect to meet if there are no application developers? And we need to make it simple for them somehow going forward to be able to develop application or whatever we have. So we need to have simplistic view of the core infrastructure, hardware, and the software stacks, so that they don't get confounded, and all the stakeholders, they flourish, they prosper. I'm sorry for this monologue, but I think that's the way I look at it as an outsider.
But I mean, that's the purpose of this discussion, to improve ourselves.
also the purpose of this kind of events. The idea of this week is to bring together, of course, these open source groups, but also people from standardization, people from research, people from external SDOs, and have some joint conversation on where are we taking this further. We're not claiming to be complete. Networks are made of bits and pieces. We're developing some of them. And at the end of the day, probably in the end networks, there will be components that will be open source. There will be components that will be proprietary, and that's fine. And yeah, there will be many different use cases to solve. And the idea is to provide options and also to provide timely feedback to standardization, just to let them know we're trying this and it's kind of okay. We're trying this other thing and it's not working for us. So the main goal at this stage is to provide feedback to standardization. Okay, thank you. I think there was another question.
Thanks a lot for this effort, and I think it's quite a valid, important, and interesting direction to go. So a bit following this last, let's say, conversation, probably looking at the problem from the SDGs perspective. I think probably we need to improve a bit the way that we put together this big picture to not create an impression of having a monolithic solution, right, that can solve everything. Because I think one threat could be just like creating this impression that there would be one layer that solves everything. And also from the SDGs perspective, there might be some risk about interdependencies that later on might come on each individual components, and they might lose their individuality, right? So I don't think we really want to promote a vision that these components cannot stand alone and they cannot work, and they need to necessarily work together in order to deliver something. Or maybe I'm wrong on that. What is your view on this?
Every SDG was pretty independent, with some exceptions and some anecdotes, I would say. It's the first time we really put the effort on bringing every piece together. We might not solve everything, of course, but the idea is also to see what we can achieve with what we have, what we're missing, identify gaps, and maybe identify opportunities for collaboration with external communities or with other kind of approaches.
So the initial view is just to move towards a future that all these components come together and work necessarily together, or we would
is to try what can we solve with all of them, or what can we solve with some of them. We might not need everything. That time will say.
If I may, because probably this is a quite interesting conversation. Probably this answers two questions. I mean, the purpose probably is not trying to claim that the components are targeting some specific elements in the standardized architectures. They already do. But we are aware that still the interoperability between components, no matter if they are open source or they are proprietary, have rough edges, have difficulties that happen in field, by the way. We have acknowledged that we have an advantage. Here is that they are open source, so we can reuse it. And we can identify those rough edges among us. But they happen between two components that are already standardized. So the big picture is already there. In theory, every component that is equivalent to a Teraflow SDN together with an OSM-like a component that is proprietary, this should work. But typically they have difficulties, right? Unless that they have interoperated. So this is the reality in the standards before the open source came. Then the SDGs came, right? And they started to do their own thing. And we realized that eventually, in order to prove that we were doing something about interoperability for real and not in the paper, we started the initiative to show that those components that standalone work and serve a very clear purpose by themselves, each of them together can interoperate. That is one of the main challenges in field. So it doesn't mean that we are just committing to only support one SDN controller, one a service order manager, one slice manager, etc. etc. No. It's not the point. The point is that at least we do the homework in field to meet what is said in the theory in practice. So we can detect the rough edges, be open about them, and work on it, and demonstrate that proprietary components can do the same. So that is that is, we are discussing about the top-down approach. Here is what is new. There is the bottom-up approach of checking that that reality says and acknowledging whatever is the limitation and working on it. That is the goal.
Somehow maybe I like the word, especially when discussing about this kind of SDG software that we develop, of reference implementation. So it's not the tool that will resolve all the problems. It's just, let's say, a tool that it does what is expected to do. Then if you want to use it, it's open. You can take it, you can download it, you can play with it, you can hack it for sure, and we are happy to see when people hacks or software. But for sure, if you want to go then to production, whatever, you might need additional steps. I mean, this is true. This is true. But at least, I mean, at least when I release things, I think on that as a reference implementation that you want to play with an SDN controller. You take it, and you use it. If something is wrong, I will be happy to hear about that, get feedback. Also, when implementing standards, as my colleagues were discussing, say, okay, this is not aligned with the standard because this and that decision. But it's also important, in my opinion, that these reference implementations are aligned with the interest of the stakeholders that will be using them. For instance, in the case of an SDN controller, let's say, if it will be a network operator that will be deploying it for some internal test or for developing a new kind of service, whatever, I think it's good to hear what a network operator is interested on and say, okay, let's try to at least bridge a bit the gap towards what they need. For sure, it's a long run work because it's not something that you can do in one afternoon. It's something that will take a lot of time, many iterations. Because with what other people say, I mean, sometimes if you are a network architect and you need different pieces than what is provided, you might need to play a bit with them. That's what you can do with open source, and then later, okay, you can keep going. But for me, that's in summary, that's what I mean is that the word is a reference implementation of what the standards should follow, and to play, provide feedback, and take some performance measurements, reference values, and so on.
One last quick question, very different from my previous conversation. So I think, are there any thoughts of plugging these things into the 3GPP for the future work that is going on for the 6G? Any of these initiatives, any thoughts in the 3GPP specs?
Implementing 3GPP specs for CAPIF, and as I mentioned before, actively contributing back and looking at what CAPIF will be in 6G and how they can help shape it. So that's for sure. I guess the other components have ideas in mind.
No, I would like to mention something, especially for 3GPP. It's member oriented. We cannot contribute as a group. I mean, we need to go as an organization there. So this is also a barrier. It's not easy because you reflect the opinion of your organization, not the SDG, at least.
Well, actually, what OpenCAPIF is putting in place is a task force where companies will revise what they're going to take as feedback or as input, and they will co-sign these contributions. So it will be, I mean, it will have, the weight will be higher because there will be a number of companies signing those contributions. And this preparation work happens in an OpenCAPIF task force. So it's like a staging area for taking that to 3GPP and making more impact. Okay. Staying with us. Please be back tomorrow. Tomorrow the conference starts. We have 2 full days of very nice talks from many different entities. We will have a lot of demos in the Winter Garden. We'll have like 12 demos each day, 12 demos tomorrow and 12 demos on Thursday. And also Thursday evening, we will conclude by kind of closing remarks and award ceremony. We're going to be giving away the award to the hackathon winner, and to the best demo. So please stay with us, and yeah, see you tomorrow.